Hello, my name is Craig, and I'd like to welcome you to the Data and AI World Tour. I lead our machine learning products here at Databricks, and today I'm excited to share with you our vision of machine learning in the Lakehouse. When people think of machine learning, many different concepts come to mind, from algorithms to hyperparameter tuning, but few people would argue the immense value it can unlock for their organizations. Unfortunately, the road from a simple machine learning experiment to a fully deployed pipeline generating value in production is one that isn't without challenge. Typically, these hurdles take the form of siloed data, inconsistent tooling, or overly complex infrastructure. Databricks solves this by providing a unified, data-centric machine learning platform built in the Lakehouse. Like the rest of Databricks, our ML products provide a holistic experience, from data preparation to model experimentation, all the way through to deployment, all using the same platform tools and governance for machine learning that you use for the rest of your data. Let's take a quick tour around. As always, we'll start with the data. Data prep and data ops take up a significant time in the machine learning process. Databricks Feature Store, powered by Delta, makes it faster and easier to ingest, prepare, and process data, and makes feature engineering seamless and accessible to both data engineers and data scientists. With integrations into Databricks Unity Catalog, you can rest assured that all your data is fully tracked and governed. Next, as you move from that data ingestion into experimentation, we provide multiple paths for you to build models, from notebooks when you want a code-centric approach, all the way through to AutoML, which automatically builds models for you once you point it to your dataset or the feature. And with managed MLflow natively built into Databricks, your teams can quickly and easily track, register, and maintain models. Once you're ready, you can deploy the model into production with serverless real-time inference, with the ability to quickly scale up or scale down based on your business needs. And finally, and most uniquely, because you're using the same underlying platform for data and machine learning, all your data, code, and models from the end-to-end lineage and governance throughout the ML process and pipeline. This ensures that you have strong tracking and monitoring of all your actions. But what makes us the most data-centric platform? By building directly into the Lakehouse, we can take full advantage of the foundation created by Delta Lake and MLflow. The Databricks Lakehouse provides a feature store that brings your models and data even closer by making your feature-rich data discoverable and reusable across various models and pipelines. With the integration of Unity Catalog for governance, your data scientists can easily turn any table into a feature. This frees organizations from having to worry about ensuring that their data science environment has all of the latest, most relevant data synced with their other data stores. Furthermore, when you choose the Lakehouse to do your machine learning, you're on a fully production-ready system where you can deploy your trained models and do serverless real-time inference with low latencies and extremely fast auto-scaling. To be honest, it's faster than any of the others I've tested. So not only do we scale up quickly, but we also scale all the way down to zero to save costs on models you may only use intermittently. Another huge advantage of the Lakehouse is that all your data, from model inputs and outputs, logs, metadata, and more, are all stored in easily accessible tables. Machine learning engineers can save precious time with out-of-the-box analytics to get you started with the essentials, such as monitoring models for drift and latency. But having the data always accessible means you can now easily join proximal data together to get a better picture of your overall business impact from your machine learning efforts. Having access to all these underlying tables and their lineage also allows you to more quickly and easily debug your data pipelines to ensure that your models are always performing at their highest potential. Now, enough talk about our vision. Let's go take a tour around the Lakehouse and show you firsthand what we're talking about. In order to tie everything around a real use case, we're going to follow an example of a consumer goods company. They want to optimize their supply chain by accurately forecasting demand at the individual store level by using machine learning and implementing an end-to-end machine learning pipeline with large amounts of product going to many locations, optimizing the supply chain by even a fraction of a percent to significant financial gains for the organization. In the past, this team has struggled to operationalize their machine learning projects due to several challenges, such as ensuring the freshest and most relevant data is accessible and always used, deploying production models quickly and in a cost-effective manner, knowing models' performance was degrading over time, and integrating model performance data with the rest of your business data to outline impact and identify opportunities. Let's jump into the Lakehouse and see how we can address these challenges on Databricks. As always, we start with the data. From the Databricks homepage, notice on the top left that you're under the machine learning persona. This tailors our UI to machine learning workloads and gives us some useful shortcuts on the sidebar. To take a quick look at where our supply chain data lives, we're going to hop into the feature store, which is going to serve as the central repository for all data that feeds into our machine learning pipeline. Being in the Lakehouse, the feature store gives you all of the benefits of the underlying Delta tables it's built upon, adding important metadata that allows you to automatically track lineage across your models, as well as the data that feeds them. This means when you create a feature table in the feature store, the data sources used to create the feature table are saved and tracked so that you can access the models, notebooks, jobs, and endpoints that build upon that feature. Now, if we double-click on one of these producers, we can see that we've set up an ETL pipeline using Delta Live tables to populate these feature store tables. In this case, we've got some data manipulation being performed to take the raw data from all the stores, add in some features, and surface it through individual store tables at the end of the pipeline. You'll see that there's a little practical difference in implementing data engineering and feature engineering. Provide consistent tooling for teams across the organization. Having reliable lineage also means that your machine learning teams will have a much easier time with governance and security, making sure that regulatory compliances can be met. Speaking of governance and security, let's take a quick look at how Unity Catalog helps us add permissions and track lineage through our data. Going into the Data Explorer, if we open up a feature table, you'll see that we can track what users have access to what data, as well as the up and downstream lineage of the feature table. This opens the door for data scientists to turn any table in a catalog into a feature table, ensuring the freshest and most relevant data is always accessible, always being used. With our data now in the feature store and ready to be made more valuable, let's move along and see how we can train and tune models on the Lakehouse. Much like the DIY approaches many of you have probably done before, we can happily jump into a notebook, attach it to some compute, and this compute comes preloaded with the most commonly used ML libraries, and you can quickly start searching Stack Overflow or one of our solution accelerators for code snippets to get you started along the path to your next project. Most of you already know how that goes, so I'll show you another path. Let's go into AutoML, which provides a way to automatically train and tune models and simply tell it that you want to train a forecasting model based on the feature store data we just looked at. All we have to do is tell it which value we'd like to forecast, what column represents your time series, and how long you would like AutoML to train models while iterating over the hyperparameters to find the best performance. In the interest of time, we've already let it train for an hour, and what you see here are the results. Now, not only does it cleanly provide the models trained along with their relevant performance metrics, but it also provides the code used to generate the models, so you can take it and further iterate upon these models if you would like. This glass box approach ensures that users have full visibility into the code generating their models, which not only helps novice and advanced users alike, but is incredibly important to meet compliance and regulatory requirements. Now, let's click into one of those trained models, and you'll notice another piece of magic. All models are automatically tracked along with their metadata and lineage, thanks to having MLflow integrated across all the machine learning that's done within the Lakehouse. Next, we'll register our highest performing model to the model registry, allowing us to further collaborate with other stakeholders and manage the full lifecycle of this MLflow model. Having MLflow managed for you and fully integrated means that you can track models as they move from development to production, as well as tracking version changes and more, all through a nice UI or via API for integration into other pipelines. So now that you've trained and tuned the model, we need to take our next step of using the model to provide value for the rest of our organization. Fortunately for us, this is simple. We go into our model and use the Serving tab to deploy our model for either batch or serverless real-time inference. As mentioned, serverless real-time inference lets you scale up your model for high-velocity queries, supporting high queries per second, as well as supporting ultra-low latencies, and scaling all the way down to 0 to save you costs when workloads are less predictable. Now, once this model is deployed, we'll wrap it up by showing how you can keep an eye on those deployed models. When you serve your models from the Lakehouse, Databricks automatically writes the model serving data to Delta tables, so you can create dashboards that let you track model performance, serving statistics, and even set alerts for things that may fall outside of comfortable or common ranges. This gives you a centralized location to monitor, integrate, and manage your machine learning workloads, so you always know exactly how your models are performing in the field. With the end-to-end ML pipeline now in place, we can see how well our deployed models are predicting at a store level, allowing us to retrain and update whenever there are gaps. This helps our organization provide the right inventory at each store each day, improving sales and inventory management costs. And to tie it all together, since everything we've seen today is built inside a data-centric Lakehouse architecture, we can easily integrate our machine learning data with the rest of our organization's data. This allows us to build out powerful live dashboards that give anyone within your organization with the proper access the means to understand what is truly happening in their end-to-end machine learning pipelines. Finally, if we zoom all the way back out, we can take a look at all those various parts of the Lakehouse we covered today through our end-to-end machine learning journey. Now, we briefly touched on how the features store, along with Unity Catalog, ensures the freshest and most relevant data is accessible and always being used. How easy it is to train models yourself or with ML to get a jump start. And finally, how models can be deployed and monitored, all from a central place with strong security and governance in mind. But you don't have to take our word for it. We have many customers that are achieving incredible results on the Lakehouse right now. Kona Services, a Coca-Cola company, has implemented a very similar architecture to what we've seen today and has seen over $6 million in annual savings by optimizing their supply chain using these techniques. Hopefully now you've got a good idea of how you can really pull the most value out of machine learning on the Lakehouse. I hope you enjoy the rest of your time watching the Data NII World Tour. Thank you.